Okay, so the last thing that I am going to show you how to do with SolidWorks is how to calculate out properties of 2D shapes. So right now I've just opened up, this is a ANSI. Actually, let's just go with a different one. So we'll do a new drawing. And I just want to grab an 8.5 by 11 inch piece of paper, which actually is what I've already got. This is that ANSI landscape. So we're just going to say okay. So there's our 8.5 by 11 inch paper. We're going to come in here to go to sheets. We're going to right click on that. We are going to go to properties, and because we're going to draw a lot, so we're going to draw a very big thing, we want to make the scale factor 1 to 200. So 1 to 200, so every inch on the paper is going to be 200 inches in real life. Okay, now that we have that, let's draw this lot. And let's see, we'll go here. I'll fix everything here in a second because that's a terrible drawing of it. So first thing I want to do is I'm going to make the bottom part horizontal. And then there's 90 degrees between these two. So I hold control and I got 3 of them there. I want this and this to be perpendicular to each other, so I'll throw that in. And then let's throw some dimensions in to clean it up a little bit more. So this bottom line here is going to be 120 feet. And so I put this in, and even though it's not set up to show feet and inches like the other one is, I can still type in 110 feet, and it writes it down into what it is in inches. So this is going to be 140 feet up here, 140 feet, and then this last one here is going to end up being 88 feet, and there we go. So everything looks the way it's supposed to look. It's kind of going off the paper, so I'm just going to drag this corner here and move this point to where it's here. And then once again, I'm going to fix that corner so it doesn't move. So there we have our lot drawn. And so what now I want to do is I want to go to evaluate. Now you do have an evaluate spot here, and you can go to section properties and it will automatically pop up and show you, okay, well what you've drawn here has an area of 46.38 square inches. The problem is that is purely based on the paper. That is not based on the dimensions because we're at 1 to 200 scale. So if you come up here, we'll use a more advanced one. We're going to go Tools. We're going to go to Evaluate. And actually, we'll go to Section Properties. Actually, I forgot. It's the exact same thing now. They've unified everything. So from here, I want to take a look. I want to change this to make it work. And so the way that I'm going to make that work is I'm going to come up here to Options. And we're going to change stuff around. I want to use Custom Settings. And so what I want to change to is I want the length. We're going to change that into feet to have it calculate out for us in feet. Bring it to 6 decimal places, and we'll say OK. And the feet still come up in like it was based on inches. Let me check something. I have something incorrectly set. Oh, I checked into it and I forgot. This will only show the drawing area. It is not going to show the scaled area. So that is my mistake. So if we go use custom settings, we'll take it back to feet. And you'll notice we get 0.322108 square feet. Now obviously that is 200 to 1 scale, so what do? We have to multiply it by 200 by 200. So 200 squared to scale the dimensions to the right thing. And so once you do that, it's 12,756 square feet. I forgot about that. I thought it did that automatically, but it does not. So that is a quick way to find the area on things. And just remember, if it's not 1-to-1 scale. So let's do one other thing, something that can help you out in some of your other classes, because you'll notice that it also had centroidal and moments of inertia properties. This will be really helpful so you don't have to do a parallel axis theorem and whatnot. So let's go back to another A-size drawing with no format, and I'm going to draw a T-beam. We are going to leave this at 1-to-1 scale, which we can see down here. And so now let's draw a T-beam, something that you would see in your strengths class. We're going to sketch, and we're just going to draw. Up here, we'll draw this, and then I don't want to do that. Let's draw a rectangle there, and we're going to go in and delete this one, because I did not mean to draw that one. Okay, and so we have these two. Let's make that 6 inches by 1 inch. And then this will be another soup with it by 1 inch. We'll make this also 6 inches by 1 inch. And then we will put this together. I'm going to highlight that midpoint there. Hold down to highlight. I'm holding down to have the midpoint show. Once it shows, I'm going to hold Control. I'm going to pick those two midpoints, and I'm going to make those coincident to slap those right next to each other. And that kind of centers everything up. And then we do need to put that on center. And then what I need to do is take this point here. I'm going to fix that point, and so that kind of puts everything together. I'm going to trim the center point out here. Unfortunately, once I trimmed that out, that got rid of both of my constraints there. So what we could do is we could sit here and put a line from there to there, put a line from there to there. And I will make those construction lines for construction, and then I will make them equal to each other. And that forces them to fully constrain, and that'll put everything into the right spot. So now we are all good. We have a fully constrained open section. Okay, and so now if we go into section properties, evaluate, we go to section properties, bam. You do not have to calculate out any of your moments of inertia because there they are. Now, it will have the moments of inertia labeled as LXX. You're used to seeing them as IXX. It's just the way that SolidWorks words things. So the moments of inertia are LXX, LYX, all down the line. And you can see right here, here we go. So it tells you here's where the centroid of the part is relative to the origin. So we look at it, the centroid is going to be 5 inches in the X direction. So that would be from the top here, 5 inches down. In the Y direction, 5 inches down. In the X direction, it's 5.3 from the origin. And so, of course, where is the origin at for this one? So, I mean, the question is, this relative, this sketch in the part origin, where is it? Well, if I go out here, go up to my visibility, and I can see view coordinate system right under it is view origin. And that brings up the origin. So, where our centroid on this part is located is X is 530, so we'd come over here and go 530 over this way. and then in y it would be 505. Go up, it would be right about there. In fact, we can even, if we want to, we could draw that in. Let's go to sketch. Let's do a point right there, and we'll dimension that in. It will not let me put the dimension into the origin, but I can. 5.3, and then y was 5. Oh, sticky keyboard. 505, and there we go. And so that point right there is where our centroid is located. Let's go back to 530 and 505. So there's our centroid, and we have our moments of inertia. So IXX, the moment of inertia about the centroid with the x-axis, is 55.25 inches to the fourth. IYY would be 18.5 inches to the fourth, and IZZ would be 73.75 inches to the fourth. And so there you go. So quick way of calculating out all that stuff that you would need for a strength of materials class.